The Cumulus Hyperconverged Service, or HCS, creates automated integration between the rich set of Nutanix Prism APIs and Cumulus Linux. HCS allows hyperconverged infrastructure administrators to deploy new Nutanix nodes without any network configuration by dynamically detecting servers running Nutanix AHV and automatically adding dual-attached MLAG bonds. Once the nodes are online, Cumulus Linux switches will listen to Prism VM events and manage all VLANs on the switches related to the VMs. As new VMs are created, deleted, moved, or destroyed, Cumulus HCS will deal with all VLAN configuration without any user intervention. To begin, connect the 1 gigabit IPMI interface on the Nutanix node to a 1 gigabit switch running Cumulus Linux. Next, connect the 10 gigabit data ports on the Nutanix node to a pair of 10 gigabit Ethernet switches that will run Cumulus Linux. Finally, using the USB image created by Nutanix on a stick, insert the USB stick and reboot the switch to trigger the automated configuration process. First, a user only defines the Prism username, password, and cluster IP address on each switch. This is defined in the etc default Cumulus hyperconverged file. Next, we confirm that we are receiving LLDP messages from our Nutanix nodes and confirm that no existing bonds are configured to those same Nutanix nodes. In this output, we can see 4 Nutanix nodes have been discovered on SWP 11, 12, 13, and 14. In the right pane, we're continuously viewing the configured bonds on the system, and we see that only an MLAG peer link exists. With this information, we can enable the Nutanix service, or the Cumulus Hyperconverged service, with systemctl. And in just a moment, as we watch the pane on the right, we'll automatically detect those 4 nodes, build bonds, transition through interface down into interface up, and have our 4 dynamic Nutanix bonds created. With the Cumulus Hyperconverged service started, first we can view the current list of VLANs on the system and the list of VLANs to each Nutanix node using the command net show bridge VLAN. We can see that only VLAN 1 exists on the system and has been assigned to each port on the bridge, including our 4 dynamic Nutanix bonds. Next, we can log into Nutanix Prism and power on a previously created VM. We can see that this VM was created with a NIC already in VLAN 10. We can use the watch command to continuously run the output of net show bridge VLAN and observe any changes that occur to the bridge. As we power on the VM, the Cumulus Hyperconverged service will receive the notification from Nutanix Prism that the VM was created and that VLAN 10 was requested. VLAN 10 is automatically added only to the interface where that VM lives, in this case on the Nutanix node associated with SWP 13. It is automatically added to the bridge and automatically added to the MLAG peer link interface. If we move this VM from the server on SWP 13 to one of the other nodes in the cluster, we'll also see the associated VLAN move from SWP 13 to the appropriate SWP interface. In this case, as this VM moved, the VLAN changed to SWP11. And finally, as the VM is destroyed and there are no other hosts requiring VLAN 10, VLAN 10 will be removed from the system dynamically by the Nutanix HCS service running on Cumulus Linux.